and welcome everyone to the strategic priorities and recommendations to make Europe's electricity grid ready for climate neutrality. I'm very happy to see many of you joining us today. My name is Adrian Timbush and I'm the chair of the executive committee of ETIP Wind, and we will be debating today a lot of findings that ETIP Wind has published in the latest fact sheets, entitled the same way as our webinar is entitled here today. So we have a great panel set up here by Daniel Freile, who will be our moderator today. I'm looking forward to very interesting discussions. Please be a very interactive audience, post your questions, have your say here, because this is also the role of these events in our daily activities and daily jobs, right? To exchange as much as possible insights and ideas and examples on the way we are going to prioritize, but also what we are going to recommend to our leaders to develop in Europe to reach this climate neutrality. With that being said, Daniel, over to you for introduction of the topic and the panelists. Thank you.
Many thanks, Adrian, and good afternoon, everyone. Yes, we have a very good panel. We will start in a few minutes with our guest speakers. I will introduce them in a bit. Before I do that, I would like to take you through some of the findings of the work from the ETIP Wind, which are being reflected in this fact sheet, but which are also, let's say, the combination of different activities that we have been doing in the last year or so, which have been also reflected in a report that we released earlier in June. So I would like to keep this conversation very interactive, as you were saying, Adrian. So I'm just going to give you a few slides also to raise some points and perhaps trigger your curiosity, and then put questions that I will bring to the speakers. If you don't put your questions, I have plenty of them, so that should be fine. But I think it's better when we get the interaction and also the perspective of those who are in the other side of the screen. My name is Daniel Freile. I'm Director of Market Intelligence at Wind Europe, and I've been also supporting from the initial phases the ETIP Wind project and platform. So let me share a few slides. So as I said, we had this, I hope you can see my slides. As I said before, we had this report launched in June. We look into the overall system transformation. We see how Europe could decarbonize with renewables and by 2050. And we saw also, we studied the implications on the system and in the power system in particular. I think one of the findings, an important one, was that we could reach climate neutrality with a system which should not be more expensive than today's energy system when you compare it to the GDP of the economy. And I think that's very encouraging, although we will need to ramp up investment significantly in the next 10 years or so. Another finding was that the system will be relying heavily on electricity. We're going to go from a 25% use of electricity in final energy demand to approximately 75% by 2050. A lot of the applications will be directly electrified. We're talking heat pumps, electric vehicles, a lot of applications in industry. But where we cannot use electricity, which is the most efficient way of doing it, then you also have to have a lot of indirect electrification through the use of hydrogen or derivatives, which can be applied to a number of harder to abate sectors. Now, in this transformation of the system, we're going to have to double the size of the power grid. We're going to have to produce double of what we're producing today. We have around 3,000 terawatt hours production in Europe. We're talking to go up to 7,000 terawatt hours. So we just need to double the size of the system, which might be easier said than done. It's easy to put those numbers in a presentation and a slide, and we can casually talk about it. But when you really think about it, it's a huge undertaking. And if you try to do these comparisons, if you say, well, we actually need to double the size of our highways in my home country, then you will be very puzzled on how you're going to be doing that and how it's going to be the acceptability also of the public and policymakers on that transition. So you really need to emphasize this. This is going to be a big thing, and it's not at all a given. So this is one of the reasons why we are doing this work, and also having these discussions, trying to better understand all together how we get there. Then maybe the other last point I wanted to highlight for this today is, well, by doubling the system, we also need to double the rate of investments on the expansion of the grid. And we need to do that rather fast, which is not also something easy. So we have a long report, and you can access to the website, but then we came with the fact sheet, which obviously is better accessible by when you have some time later. You can print it out. This is not meant for a PowerPoint, let's say. This is very busy. So what I did was to highlight the 4 mega trends that we see and the energy system transformation. These are trends about technology development, but it's also about trends on the way we make a governance of this energy transition. So I'm going to just give us a few highlights in each of these 4 pillars, and then we're going to have the discussion with the speakers also organized around these 4 pillars. If you go to the first one, it's about grid expansion. And here, I hope you can see the mouse. Here it's about expanding interconnection between countries and also within countries. It's putting more overhead lines, but it's also about developing new technologies such as superconductors, or and then using all the possibilities like underground cables. We're gonna have to develop a lot of this. It's also about reinforcing our distribution grids. A lot of renewables are connected to the distribution, but also new loads like electric vehicles. And it's also about coordinating this deployment of the grid with other infrastructure, such as the natural gas and the future hydrogen infrastructure. So how do we get a governance to do this all in a smart way? When you go to offshore, the ambition is huge. We're talking about 450 gigawatts to be installed from almost 20 gigawatts today. So that's a huge transformation. So we need an offshore grid. And so how are we going to be designing this? How are we going to be putting the technology? And there are some concepts like energy islands. How are we going to be shaping this? There is another point, which is the deployment of offshore hybrid, which is basically while you're deploying the grid infrastructure, how do you also embed power production from offshore wind, so that you can also use the electricity where it's more used in an interconnected way. I'll give you an example. This is a map of the North Seas. You see on the bubbles, you have wind farms in yellow, the ones under development, in green, operational ones. And the same for the interconnectors. Those in operations are in blue, in green, those under construction, and the yellow ones, orange ones are under development. And what you can see here is a kind of a spaghetti dish. Yeah, so you have many things here, and there doesn't seem to be too much coherence. Although every single project is well developed and coordinated, when you look at this, you can see that there is a huge room for an improved design of the future grid, where you can cluster much more, where you can reduce the number of landing points, which is also a particular barrier for the deployment of offshore wind, but also for the interconnectors themselves. So there is a lot of benefits of having this, let's say, a master plan for an offshore grid. So we need to look into that trend and how we make that happen. The second pillar, it's the grid efficiency. And here we can talk about a number of technologies that we will need to deploy while we are expanding the grid, but that they can also be deployed in their existing infrastructure, which in most cases are not utilized today. So they are available in the market, but they are not used in most cases. And here we're talking about like synchronous condensers could have a good way of reducing dependency on synchronous generators or conventional generation. You can look into advanced monitoring to better understand your grids, the temperature, to maximize that, the new technologies in the converter, and whatnot. Yeah, so all this we need to address it, how we bring it into the system in a systematic way. And then you have issues about resilience, both from cyber attacks, but also from extreme weather events. And we have seen a few of those lately, also in the US, extreme weather, cold weather, but also floods here in Europe. And we're gonna have more of this. So how do we make the system resilient to that? And how do we make the system interoperable, so that we can bring a number of different technologies which can work well with each other and then counteract. The third area is system flexibility. And here what we did as well was to assess, this was in the report, we assessed the flexibility needs the system is going to have in the future. This is a bit complicated chart, but what it shows you is that from today's, this is for Germany, and and the line is the residual load. So this is your total load minus the available renewable variable capacity, so wind and solar at any moment. And what you see is that over time, the needs are going to grow. And you can see that the needs are different between the time period that you choose. So I'll give you an example. Daily variability is going to go from around 14 gigs to 40, meaning that within a day, your system is going to change more than 40 gigawatts. So as an example, you're going to have in the evening the solar PV ramping down because there is no more sun, the demand going up from heating. And so you're going to have to cope with that change of variability up to 40 gigawatts in a couple of hours. So how you get the system ready for doing that? And that flexibility, you will also need it in longer periods. The good news, that's what we show, is that the technologies are there. So it's a question of finding a strategy on how to deploy these technologies in the most efficient way. But you can get flexibility from the renewable assets themselves. You have also a very important role for storage, both battery, but also pump hydro storage, as well as storage through the use of hydrogen, potentially. And you have also all these new loads like electric vehicles, which can help also on charging in a smart way, and can also be connected to the grid to provide a number of additional services there, because there will be plenty of capacity on those batteries that we could, in principle, use if we do it right. And then you also have all the flexibility coming from potential electrical demand on buildings and industry. The final point is renewables-based electrification. So as I said before, we're going to have to use plenty of electricity. So this is a challenge in terms of building the size of the system, but I think it's also about managing the time of use of that electricity so that we make it in coherence with the available renewable resources. So plenty of electrification we see in industry, in buildings, in transport, in road transport, and then we see also this role, as I mentioned before, on the use of hydrogen. And here we need to work on the transformation process. So how do you make hydrogen efficient? How do you then take it to the final use? And how do we ensure that when we produce this hydrogen, we can do it in a way which is also working out for the integration of renewable energies, which is something that we'll also discuss in a bit. Okay, so having gone quickly through the different elements, I will now get back to the panelists. So we have with us, first of all, Vera Silva, who is Chief Technology Officer of GE Grid Solutions, and who is leading also all the engineering team there. She's responsible for designing and producing products in high voltage equipment, HVDC, grid automation, and so on. And Vera is also well respected in the research community, where she's been writing plenty of papers. We have also met in her previous job, also in those tasks. And she's at the moment working as or representing T&D Europe as a vice president. So hello, Vera. Christian Holm, he's a technical director for renewable solutions in Equinor. He's worked closely of 20 years in the industry, predominantly focusing on offshore wind technology. And he's now heading the strategic supplier and technology strategy at renewables in Equinor. So hi, Christian, welcome. Rena Guavata, so she's a business development manager at Ampasimon, and she's also the vice chair of Current Europe, which is a freshly created association looking to promote the use of grid optimization technologies. She's been working for around 15 years, and she's been doing a number of jobs also in consultancy and for the Australian energy market operator. So welcome, Rena. And Jean-Baptiste Paquel, who is a system planning manager at ENSOE. He's been there for the last 8 years or so. He's quite well experienced on resource assessment exercise, the 10 years network development plan, and how we get the grids from a conception to implementation. He's also teaching the international energy management courses in the means of Paris Tech. So welcome, Jean-Baptiste. Good, so we have a great lineup. So let's go straight to the first area or the first topic, which was grid development. And the first question is going to be to you, Jean-Baptiste. You've worked a lot on developing this 10-year network plan, yeah, for the grids, and you do it also together with ENSO-G. So you have this, let's say, combined vision. How do you think we can adapt this process to reflect a higher ambition that we have today at European level?
So hello everyone. Thank you, Daniel, for a good presentation, and the response is in the picture that you showed us before. The new world is really complex. So first of all, well done, because it's a really good representation of all the challenges that we have to address. And these are many challenges. So of course, the 10 years network development plan and also the planning tools within every European countries are going to evolve. We are waiting for a new TENI regulation, which is going to drive us in the right direction, but probably we're also going to go even beyond. And there are many aspects. So for instance, of course, one of the main elements of the new TENI is the offshore plan. Up until now, and probably we can rediscuss it in the future, our plan was not adapted to assess the new type of project which we need to put all of this offshore in the European seas and use it as usefully as possible for Europeans. So we need our plan to be able to assess the different solutions, for instance, between a hybrid project, an energy island, or shore-to-shore connections and so on. And of course, it gets more complex. So our plan has to get more sophisticated as much as the actual planning has to become more sophisticated. It's not the only area. Of course, the sectors are becoming more and more interlinked, coupled, we say. And so we're already, as you mentioned, working with ENSOG. In the future, we are going to be working much more with the DSO level. And we also have a plan to integrate more and more sectors. Obviously, looking at the biggest targets first, so that would be heating, but then in the future, transport and so on. In the past, TYNDP, for instance, the one we released 2 years ago, we had for the first time a project which main element of value was actually transport. So we were a little bit lost. How do we assess that? We had absolutely zero way to do it. So we have to evolve for all of that. But just to terminate on that, this is just the evolution of a tool. What is consistent in what this tool is showing to us is that we need to move fast. We need to develop all of these solutions. So essentially, I fully expect that the next versions of the TYNDPs are going to show us that we need to pull as much wires as we need, but not only, of course, working on the non-wire solution and on all of the developments, which are not competitors, but just part of a gigantic jigsaw puzzle.
Thank you, Jean-Baptiste. Rena, how do you see also the evolution of TYNDP? I mean, we have seen also ENTSO-E doing some work on identification of technologies, which is something that you're also very keen on exploring. So what are your suggestions?
Yes, thanks. Yeah, the 10-year network development plan, as I understand, is a legal mandate to indicate these critical areas for development towards achieving this European energy policy in a safe and affordable way, right? And there are concerns about the scenarios to adequately reflect the decarbonization targets. But these concerns aside, I would like to raise another important point here about the technologies, as you say. And these technologies that are assumed to be operational in the 10-year network development plan. So besides those classical reinforcements of transmission lines and substations, and what they call non-wire solutions, as Jean-Baptiste already mentioned it, like phase-shifting transformers or HVDC control capability, storage and peaker plants and things like that are considered, right? But there's also an array of other technologies that are already at a high technology readiness level, and they're already tried and tested, and they're already endorsed by ASA, the likes of International Energy Agency, International Renewable Energy Agency, ATIP, here we are, Renewable Grid Initiative, Agora Energiewende, DENA, so on and so forth. And these are not considered necessarily in the 10-year network development plan. And so these are things like dynamic line ratings, the power flow control devices, the superconductors, and many of them are recognized by ENTSO-E as a technology, meaning all European TSOs recognize these technologies in the form of what they call Technopedia. This is available on ENTSO-E's website. And in some cases, like dynamic line rating, some TSOs are already, they have deployed these system-wide, or they have also concrete deployment plans, like in Germany, Austria, and France, but still they're not considered in the 10-year network development plan. And so it could be argued that modeling them in the 10-year network development plan will not materially change the need for the critical areas for development, but it also undervalues the significant importance of these technologies in ensuring an efficient build-out and the use of our grids, bringing the benefits in terms of keeping the energy transition at lowest cost as possible. Daniel, I don't hear you anymore.
You're muted. Daniel, you are muted.
Okay, can you hear me now?
Yep.
Okay, I think I pressed the button here with my elbow. Okay, I was saying, Vera, that we also heard from Jean-Baptiste saying that, well, there is a big area for improvement also, which is the offshore part, and we could see it also in the slides on the work of the ETIP wind. You are quite involved on the development of the technology to enable that offshore grid actually happen. How do you see that? How do you envisage the operation and the deployment of the offshore DC, I will assume, grid? You are also muted, like I was. Now we don't hear you. Okay, look, while you're trying to fix your mic, I'm gonna actually pose a similar question to Christian, because Equinor, you are also very involved on the offshore deployment, and you are, trying to do also your own DC mini grids or projects. So how do you see how do you envisage the operation of this grid, which is a big undertaking?
Well, it's first of all, thank you for the invitation, Daniel, and thank you for a really interesting topic. This is for sure something that is important for us as we are embarking into this renewable journey. And when we're looking at the connection right now between our operational wind farms and the national grids, it's quite easy. We have a responsibility from the wind farm all the way until the connection point that we have agreed on, and we are following the grid codes and standards as such. And that's kind of the beauty with the current system. It's easy, and it's something that's understandable and easy to control, also from a risk perspective from our side. When you're discussing larger offshore grids, that is also going to connect several wind farms, that's for sure interesting, because it could be an extremely efficient way of doing it, cost reducing for sure. But you also need to take well care of the risk aspects and who's doing what. I think with offshore wind, we're really seeing the large wind projects. We haven't seen that the same scale on onshore wind projects, but with offshore wind, like with the Doggerbank project, we are currently employing 3.6 gigawatt. It's really large projects, and they are. I mean, if this project doesn't work, it leaves a dent in the national grid, in the power system of that affected country. So we have a responsibility to make sure that it is working and that the delivery system is also working as it should. So all of this needs to be proper planned, and we need to have an alignment and understanding on how this is taken care of.
Okay, thanks a lot. Vera?
Hello, can you hear me now? Yes, excellent. Sorry for the technical issues. So I'll go back to your question about the importance of having a coordinated approach to developing the grid to connect offshore. So we have a huge ambition in terms of offshore connections. You showed it in the map. There will be quite a lot of these connections that will be DC, HVDC connections, and definitely there's one aspect which is the spaghetti chart you showed. That's definitely not the most effective way to do it, just with point-to-point connections, and hence looking into multi-terminal HVDC is quite critical to get this. So there's one aspect that I would like to mention from a technology provider, which is making sure we have visibility on these new projects, and that's why the exercise of ENTSO-E, it's a good exercise because it's a cost-benefit assessment of projects, and it's a good input for us. So when we plan not only technology, but also engineering capability to deliver, these are engineering intensive complex projects. So having this visibility between the industries is very important to make sure we have the capability to deliver. The second thing is obviously it's about the technology. So there's two aspects, and I think Christian already mentioned it. Given the number of projects, I don't feel we can go into a customized approach project per project. It's very difficult to develop all the different technologies and then meet overly specific requirements. So what we need is to have a good alignment in functional specifications, like number of control schemes as well as typical ratings. So this is this is something that can really help us. That's how the AC grid was developed, and it will definitely take us a step closer. We have to have quite a lot of collaboration between technology providers, offshore wind developers, and transmission grid operators to get this type of alignment. And obviously align with standardization bodies. So Christian said when we have the standards and regulations, it makes it simple. But when we entering this new area, multi-terminal, multi-vendor, HVDC links, we're somehow entering the unknown, and standardization might be too slow to meet the energy transition. So it's important that we start already working in collaboration and feed information into the standardization. It's somehow a way of changing. And finally, it's very much about how we manage the risk of this kind of first of a kind technology solutions. So if I look back into what we do with the AC world or more mature, we look at the technologies, we look at standardization, prototype lab environment, and then an industry scale demonstrators until we actually have a product ready to go to market and general, because that's how you mitigate the risks of how things work in the real system. When we're looking at multi-terminal HVDC and interoperability aspects, we can't do it that way because we won't be building a pilot for each independently. And so we need to find this approach to work with TSOs, with the offshore developments, so that we can carry some of the operational risk of this first of a kind. And this is why within T&D Europe and the industry, we work together to have a large project launched with the European funding, so that we can actually work between different HVDC players as well as grid operators to start testing this type of solutions.
Okay, thanks a lot. I have a follow-up question for you, Vera, but also maybe for Christian. Would you talk about how we're gonna get to large scale? You need to go modular, as you say, and standardize concepts. You cannot do all tailor-made. Yes. It has to be interoperable so that all the parties can contribute to that. All great. And I think we're getting there. So we can see it also from the trends from the industry, the big announcements on type of collectors or new platforms and this type of solutions. But from a grid operation and functionality point of view, how do you see this new grid functioning? It's going to have a large array of new, let's say, functionalities and services. Are these services going to be coming from the wind farms? I think, Chris, as you mentioned, we're going to have a 3.6 gigs wind farm. If this disconnects, you know, the system gets naked, yeah, in a way, so you cannot allow that to happen. So what is this wind farm bringing other or future wind farms? You're going to put a lot of equipment there, which give you all these new type of services and whatnot. Maybe you want to go first, Christian, or Vera?
Go on, Christian.
Okay, thank you. First and foremost, we need to take utmost care in what we're doing. We need to know what we're doing, and standardization, as Vera is alluding to, and also ensure that we have a certain maturity level technically is crucial, I think. Your report is clearly stating that we're going to deliver 75% of the energy in the European Union by 2050. So that this stuff needs to work. So that's also given. And I think there is a number of things that we can do. Also, as an operator, Equinor can provide a lot of services from our wind farms. That also helps us to stabilize and support the grid. But that also needs to make financial sense, right? There must be a market mechanism that covers that, and I think we still have a way to go there in order to get that in place. I look at this energy transition basically as an open book. It's the book of the big book of energy transition is currently being written by the likes of people around this table and the people that are listening in. And it's not the last page is by far not written yet. We don't know how this is going to look like in the end. We have a number of available technologies that are exciting and cool, and with different maturity levels that we need to continue to develop and test. But we also need the market mechanisms and incentives, and also take into consideration that this is in the end critical infrastructure. We are taking a huge responsibility here, all of us. But it's we are. I think this is interesting. This is going to be really cool, I think, going forward. So I'm looking forward to the next steps.
Thanks, Vera.
Thanks, Christian. So I think, yes, the book is being written, and there's many writers that need to take a role. So I would say from the technology perspective that it won't be the showstopper. Ability to get the wind farms providing grid forming or ancillary services, HVDC controls, I would say technically we can get this grid to work, even though there's quite a lot of things to write. But we also need the roles and responsibilities to be clear. As we go into a meshed offshore grid across countries, we need to have an operator that takes responsibility for this grid and coordinates these services and technologies, and that as well as the market design that remunerates. So I would say today, at least from a technology development perspective, is if it doesn't create value to our customers, it's difficult for us to put the priority in those R&D investments. And if our customers don't get a market to bring value to them, the chain is somehow slowed down. So a lot of work done with ACER recently on hybrid offshore connections, still some barriers to go, like this 70% rule. So I think we need to continue working together, but we need clarity in terms of who's going to operate these grids, what is the market design that's applied, and how can we maximize the benefit of these connections.
Yeah, very good points. And I that's basically a good introduction to the second pillar, which is grid efficiency. This is maybe for you, Rena. I think I saw you also nodding. The technology probably is there, but how do you see the main challenges? So you mentioned it before, no? Bringing this into the grid planning process. Why is it not happening, at least at the speed that what we think should be?
Yes, thank you for the question. I'll come to that towards the end. I think I want to start with saying that digitalization is really key to operate our grids more efficiently, because this means operating them closer to the physical limits, and we absolutely cannot compromise safety and reliability. So with digitalization, I mean increasing observability and controllability of our grids. And for transmission grids, we have some monitoring and remote controllability in substations, but in distribution grids, smart meters allow better visibility, and this can be leveraged to provide aggregated services and so on. But there is room for improvement, especially in terms of the wires monitoring and the controllability of power flows. So in terms of the grid efficiency part here, sensors installed on power lines, towers, in substations, optic fiber-based sensing, and image processing, these things can enhance our visibility in real time. And combining these measurements with weather forecasts and processing them with algorithms using artificial intelligence, this can help us predict and prevent critical conditions. Power flow prediction and control, this also has room for improvement, particularly in distribution grids. And to date, TSOs are improving this aspect, but certainly no DSOs are in the mindset to implement this. I don't know if anybody is from Germany, but if you are from there, you probably noticed the huge scramble by the DSOs after the Renewablesbased 2.0 requirement took effect. So that's a testament to this. Their business framework set by regulation allows them to over-dimension the grids and recover the cost plus revenue. This is where the problem is. They are sitting in a comfort zone. So here, this is the aspect, one of the aspects that's been pointed out by a recent ASA position paper called Infrastructure Efficiency, the role of regulation and incentivizing smart investments and enabling the energy transition. That's a mouthful. And that in this report, or this position paper rather, it pointed out that return on investment was more than 7 times higher for conventional infrastructure investments versus revenue from innovative solutions. So herein lies the problem, I think. And also another groundbreaking report that was published just yesterday by Consentech, a German consulting company, called The Benefits of Innovative Grid Technologies. This report also showed that congestion management costs like redispatch and wind power curtailment can be reduced by up to 90% by using innovative solutions like dynamic line rating, modular FACS for power flow control, and superconducting cables, which can be used for both transmission and distribution. So for our grids to be efficient, safe, and future-proof, they need to be intelligent with enhanced visibility and controllability. That's my aspect.
Thank you, Rena. Jean-Baptiste, do you, I mean, not on behalf of the DSOs, but at least on behalf of the TSOs, do you think that they are just sitting in an uncomfortable situation, or it's a bit more complex than that? And probably, I think Christian also talked about, well, when you go big, you need to have also certainty that the technologies are very mature, because there is a lot of risk. Do you see also hesitance about certain technologies which might have not been proven to a very large extent, or is it really about the regulation and the incentives?
Well, I can tell you about what I see at the Brussels level, trying to develop a plan. 10 years ago, we were just pulling together some Excel sheets from every country in Europe and calling it a plan. And now we are somewhat expected to create a gigantic model where the behavior of every European is going to be there. And there is a very famous sentence which is important to remember by George Box, a mathematician, every model is wrong, some models are useful. So that's the first thing. I'm not going to comment if the DSOs are working on a comfort area. For sure, there are areas of the regulation that need to adapt. I fully agree with what Rena says when she says that for now, the mindset to evolve is not sufficiently shared. And with the DSOs, there's going to be a challenge due to the nature of the organizations. Many of them are really small organizations that are going to need to scale up their expertise quite significantly. And that's a big challenge in how this can happen. From our perspective and what we do, yes, we are all in for a future world that is much more digitalized, that is much smarter, and we are all in also to do the studies that are going to show it. That might be our next steps. Currently, and if I want to respond to also what Rena said earlier, that we currently don't see enough of these solutions in the TOI NDP, and she's right, but also that's because of the nature of the exercise that we are doing. We are trying to answer to specific questions. One of these questions might be, how do we integrate these smart technologies into the grid? Might not necessarily the best place to do it, but for sure we can speak about it. But what we are trying to show with our study is where do we need to get better? Where can we invest to bring benefits to European in the grid? And when we say investing in the grid, if we see somewhere that's solving an area where electricity is locked and prevents us from reaching benefits, this is for the market to find the solutions. I mean, sometimes the solutions are going to be pulling a wire. Usually it takes 20 years. It ends up being quite interesting to have a network, but it does take 20 years. And the really thing that the market needs to bring all the solutions that we can to solve these locks.
Okay, thanks a lot. Let's move on to the next topic. I mean, you say, Jean-Baptiste, it can take a long time to build these grids, and that's clear. Also, to deploy certain technologies, it takes some time. But now we have all these scenarios, 2050, plenty of renewables and electrical loads, and so this is going to require a lot of flexibility from everyone. And so obviously we see a number of investments. The technology is also reducing costs. The storage is just, battery storage is becoming very, very interesting as well. Maybe a question for you, Christian. How do you see the evolution of storage or flexibility in general? I mean, do we see the flexibility coming from the power plants, from the newer power plants, so wind, solar, and so on? Or we still see flexibility rather from a standalone perspective, somewhere in the grid, operated by someone else?
Well, the wind turbine itself doesn't offer much flexibility. We can basically ramp it down, so we can reduce output from it. But in the project, we have the ability to add a lot of additional features to what we're doing that can enhance flexibility. But it's important to also ensure that we have the market mechanisms in place in order to be able to offer that. The European Commission has a goal of 30 gigawatt wind going online by every year, and that means about 80 megawatt is going online every day, 365 days every year, year round. You have 80 megawatt coming online. So this is a massive undertaking, and we need to take into account also sustainability issues. The building of grids are going to take up land area and be a challenge in many aspects. So perhaps the easier low-hanging fruit is perhaps to combine by adding more copper to the mix. Would be also to really focus on market mechanisms. So you'll get the added features from the wind farms that really supports the grid.
Okay, thanks. What do you think, Vera, about the deployment of flexibility? And maybe I also combine it with one question, which is coming here from the audience, which is linked to the previous discussion. Whether we can imagine a way of integrating certain KPIs for the regulated revenue so that we measure the smartness of the grids. Yeah, so that we rate them. But probably maybe you start with the flexibility and try then to address the other one, if possible.
So I'll try to complement what my colleagues already said, which I fully agree. So on the flexibility piece, I think that there's largely the flexibility we can get from centralized plant, and that's in place. There's some evolutions in terms of also the ancillary services market, and with the integration in Europe, trying to accelerate the access to flexibility from different systems. There's two areas that I feel are not yet completely explored, is how we access flexibility from resources connected to distribution. So requiring quite a lot of coordination between transmission distribution system operators and ensuring that we can deploy it. Quite a lot of this will be played within what we have on advanced digital software to get us and observability of these resources. So it's from a technology perspective. The second one is the flexibility you can get by technologies in the grid itself, which Rana mentioned before. Being dynamic light rating or facts, we can get a lot of benefits for congestion management and stabilization of the grid, but it's very difficult to measure the benefits and compensate it yet. And so often, I really think this new ACER position paper in terms of developing smart technologies takes us a step towards, but we still need to see how this is going to be implemented. So for me, there are these two areas of flexibility that we will need to do better because we can explore more of it.
Okay, thanks. So you say it's difficult to measure also the benefits of these grid technologies. Rena,
yes.
You see it on the current association, you are basically looking at this, how to, you just mentioned about the benefits of from the study you just did. Do you have suggestions on how to integrate this into a regulatory process and the work of TSOs in developing their grid plans and operating their grids?
Should I mute myself before speaking? Yes, I tend to agree with the suggestion that's made by ASA in terms of integrating that somehow into a cost and benefit assessment. And with the benefits there, they mean the benefits to society or to the larger consumers of electricity. I understand that sometimes, or most times, this is difficult to quantify, but there are ways to go about it. Some of those methods are already established within the TYNDP itself. This new report that I mentioned by Contentech also quite concretely quantifies some parts of that in terms of avoided congestion management costs, avoided curtailment of renewables, avoided redispatch costs. You don't have to make it super perfect, I think, but at least you have to attempt that. And where there are things that you can quantify, then do it, right? Because I think that is not put forward, or even if there are TSOs that did attempt to quantify it, because internally within their own organization, they also have to justify that investment. So they have done some kind of cost benefit analysis, but this is not disclosed, perhaps, right? So I think this is also an important point. We need to share the best practices, share those knowledge that we have already from our experience. This is also quite an important point.
Okay, thanks a lot. I'm just looking at the clock, so we are running, we're coming to the end. But I wanted to touch one point, at least one question for you, Jean-Baptiste, on the fourth pillar, and this was about the renewable-based electrification. And for those who are not in Brussels, you might have not heard yet, but the Commission is coming up with a new package of legislation for hydrogen and decarbonized gas regulation. So that they're going to announce this next week. So this is an important piece of regulation addressing the gas market and hydrogen. And as part of that, they are there's some suggestions which still have to be finalized, but on the creation of a potential new body in the future, like similar to ENSO-E and ENSO-G, but for hydrogen. Could you share with us a bit, Jean-Baptiste, how you see that, the potential evolution, and how you see that? Because I mean, one of the points that Vera said, I mean, today we cannot even utilize the whole flexibility from the distribution grid. So there is a lot of work needed in terms of coordinating DSO and TSO grid. There will be a huge of hydrogen being produced and consumed. Probably we also need to coordinate the production of hydrogen with the power grid and the consumption and so on. So how would you see that those developments?
Yeah, true. Well, I mean, regarding the creation of another organization, I mean, this is for now a leaked package. We'll see how it goes. I think, I mean, that might be a third sister for us after the ENTSOG on the gas side, who we are currently mostly working on the hydrogen, by the way, and the DSO organizations. What we think on the hydrogen development is, well, yes, indeed, we have to work with others, and for sure, like everybody in Europe, we see quite clearly that at least some of it seems to make a lot of sense. And frankly, that's so and so we got out, I think 2 weeks ago, a position paper on hydrogen, which I like to call a common sense position paper, because there is nothing revolutionary in it, and it's very close to what you published. So yes, there are areas where hydrogen seems like a super good idea. For instance, it's indeed very complicated to bring back and very expensive to bring back the electricity produced offshore to the continent. So how do we do that? Probably there is a good role for hydrogen here. There is also a good role in the sectors that are hard to abate. From our perspective, we really want to be able also to assess the actual and look at the benefits. We spoke about benefits before of possible hydrogen infrastructure in its entirety. I don't think, and I don't think anyone thinks that it's fair that we would give a white check to a technology without checking what its impact is going to be or what its cost is going to be. For me, calling it a backbone of the European energy transition is maybe a little bit premature. For sure, it's a very important element, but we have to be able to quantify it like we did in the past 10 years ago. If you were speaking about a scenario with a gigantic amount of renewables, people were coming to you and saying, look, you have to show me that it's profitable and where is the break-even point. And that was normal. And that's what we need to do with hydrogen. So we really welcome the fact that with the new TENI and this package, there seems to be room to properly assess the projects of hydrogen so that we can properly quantify. And we need to do it quick because obviously the amount to which hydrogen is going to play a role in the future systems need to be known quite soon, because it's going to impact the infrastructure that we need, and in particular the infrastructure that we currently need for gas. So we need to call a cat a cat. If we want to do gas, let's do gas. If we want to do hydrogen, let's do hydrogen. What's important is that we look at the reality of the figures and that we are able to assess it. So I hope that, and coming back to the first question you asked me, that's really one of the direction of the TYNDP, and when I think we have a very strong responsibility to inform Europeans.
Okay, very good. Thanks a lot. Christian, would you like to say something on that? Because have you found that break-even point? You are developing those projects and looking at all type of technology possibilities?
No, and I don't think that's possible yet. As in danger of sounding like a broken record, I really believe in also ensuring that we have the market mechanisms, as I have said several times, and in both to ensure that companies like Equinor applies these type of technologies in our projects, but also ensuring that the available technologies are applied on the consumer side. For instance, use of batteries and electric vehicles to balance this. If the energy prices are fluctuating, there will be a market for this type of technologies, and I think they will be applied. There are other technologies that are not is well suited to balancing. For instance, green hydrogen needs a stable production, so that's also something you need to take into account. So, but there will be a number of mechanisms available, and I think there is going to be a market for this for sure, as we are getting more and more renewable energy into the mix.
Okay, well, thanks a lot, Christian, and thanks to everyone for your time and for your insights. I think that's all the time we have today for this discussion, but I'm sure we're gonna meet again very soon in a different forum to continue discussing all these very important points. So much appreciated. Adrian, bringing the ball back to you, if you would like to have some closing remarks.
Hey, Daniel and team. Well, thanks a lot for great insights. Right? It's very interesting discussions. I think what I take is that we kind of are aligned, right, in the direction we want to go. We are coming from different corners, as the discussion showed here, right, what needs to be done. I sense a source of urgency that we need to start doing it, right? We need to start collaborating even closer than before to really start implementing these things down. It's not an easy job, right? Knowing that all of us have also other topics on the table to start working, but if we don't put the effort into it, really and taking the time to design it properly and to address it properly within all layers, right, within Europe at the political level, and then within the economical and with the technologies that we have at hand and with the roadmap of these technologies, then nothing would happen, right? So I will then encourage everyone, not only in the panel, but also in the audience that was here with us today, to really think about what they can do really to accelerate this, to help us all putting on ground the right solutions, the right technologies to make sure that we are getting fit for 55, but we're also getting set for 2050 and really decarbonize the energy sector in Europe. With that, also my personal thanks to the panelists today here, and also to you, Daniel, for moderating these sessions, to getting out the substance, and I hope the audience got very insightful insights. Right? Thank you all of you for being with us today, and stay tuned on further engagements and further activities from ATIP Wind. Take care and stay safe.
Thank you. Bye-bye.
Thank you. Bye.